Hi, everybody. This is Amy Cameron here. Apologies for the slight delay in getting started. Had a few technical problems, but hopefully we are all up and running now. So for all attendees, our organizer hasn't been able to join, unfortunately, but hopefully Darius will be on a bit later and help manage the questions towards the end of the webinar. So just a bit of housekeeping before we get started. The webinar should last about 30 minutes and we're recording it, so it will be available to everybody later. Apologies again for the noise, it's a fire alarm in our building. Oh my God. All right, there we go. We should be ready to go again. Yeah, so it should last 30 minutes and we'll have a time for questions at the end. So in your panel, you should be able to see a little box for questions. Please type those in as and when they come up and we'll address them at the end of the webinar. And if we don't have time to go through your questions today, then we'll try to get back to you after the webinar is over. So we're here today to talk about blockchain for telcos. Our title is Where is the Money? So we're trying to think about what's the potential business model, because we're at a time when I think a lot of people understand a little bit about what blockchain is, but still trying to figure out how it might be valuable to them and where they should play in this market. So we're going to use two use cases in digital identity and IoT to illustrate what the role might be for telecoms operators. And these are just two of many different areas where telcos might be able to engage with blockchain technology. But we decided to go into a couple of use cases in more detail to try and clarify the opportunities. So today, the agenda is an overview of existing blockchain business models. Then we'll go through the two use cases. And finally, we'll finish with some key takeaways and discussion. All right. So the way we see it, there are two business approaches to blockchain. The first one is blockchain to make money. And the first type of people using blockchain to make money are those who are providing the mining compute power for public blockchains like Bitcoin and Ethereum, where if you're a miner and you provide the compute power, then you get rewarded with the cryptocurrency. And so that's how they're making money out of blockchain. The second type of companies that are making money out of blockchain are those who are offering services based on proprietary blockchain or blockchain related technologies. So a good example of this is Guard Time, and they developed a technology called KSI that's very similar to blockchain in a lot of ways, but it's a proprietary solution. It's not a public blockchain like Bitcoin or Ethereum, and they work directly with companies and with governments in order to provide security solutions based on their technology. The other icon I have there is called Filament, and they operate in the IoT space, and they use some public blockchain technology to power their IoT solution, as well as putting cryptography into hardware. And so they have some proprietary solutions that sort of straddle the blockchain world. The third type of company you have are those that are contributing to open source blockchain protocols. So the actual blockchain protocol is open source and anyone can use it, but they're providing professional services or software on top of those to help others deploy the blockchain. So for example, Ripple, which I'm sure lots of people are familiar with in the financial services area, they have proprietary software that works on top of their ledger, and that's how their business model works. Um, so that's the third type. And the fourth type are people who are developing distributed apps that are powering sometimes paid for services on open source blockchain platforms. So here you have things like Ethlance, which is basically an Ethereum version of I've forgotten the name of that freelancing company, but it puts freelancers together. Or Storage, which is a cloud computing company that's a little bit like Dropbox, but works on a decentralized ledger. EOS is just a token that works on the Ethereum ledger, but is about to launch its own ledger. So companies may start as decentralized apps on the Ethereum ledger or another one, and then branch out into their own space. So from our perspective, these bottom two areas are the best place for telcos to consider participating in the blockchain ecosystem. But the main thing to remember is that the whole point of blockchain is that it's decentralized. So telcos need to sort of remove themselves from some of their traditional thinking and realize that the value is not in owning the ecosystem. So none of the software providers that are creating these protocols are trying to own the ecosystem and fully control it by themselves, but they're trying to create services that cannot exist without decentralization. Decentralization is the core aspect of enabling trust or transparency in the system, and they're helping others to engage in it. So they're helping those who are not familiar with developing blockchain protocols, are not quite sure how to roll it out if they want to use it. They're providing those extra services to make the system work. And likewise, there's some stuff that blockchain doesn't do, but that needs to be done on the side, such as sensitive data can't necessarily go on the blockchain. So these companies might be helping with moving the sensitive data around that's not necessarily on the blockchain. And we'll go through that in a bit more detail with some of the examples. So that's blockchain to make money. The next option is blockchain to save money or do something new. So these are the people who are on the other side. They're buying the blockchain services, or they're engaging with the blockchain protocols that others have created. So in terms of saving money, that might be eliminating an intermediary. And we're still at the early stages of that because blockchain is a new technology and can't go in. It's not really mature enough to go in and eliminate all the intermediaries now. But that's the promise of a decentralized solution. Another example is to disincentivize corruption. So if you have a public ledger that everyone can see, or public permissioned, where those who have permission to access the ledger can all see what happens, then it makes it more difficult for people to steal things in a supply chain, for example, because it makes it much easier to pinpoint when said item disappeared. In terms of doing something new, a lot of what the blockchain is for, or what people are thinking of using it for, is providing auditable proof of consent. And the idea is that because you have a transparent ledger, anyone can look back, and because it's immutable, you can't change it, then you can be very sure that what's put on the ledger will be there in the future. It doesn't require, if it's a decentralized system, then if one party falls out, it continues to work. So if you have a centralized provider of a solution and they go out of business, then you might not be able to access that data in the future. And ostensibly, this shouldn't be a problem with blockchain. So it provides an immutable and auditable proof of consent. And which I just touched on a little bit, it helps to manage ecosystem participation. And I think for telecoms operators, this has been a difficult challenge in that the cost of setting up a partnership between telecoms operators can be very high. And for that reason, when new parties want to join after a system is up and running and working, and those who founded it spent a lot of time trying to make it work, somebody wants to join, then it's, you feel like it's not fair. They didn't put in the work. And likewise, if one of the founding partners wants to leave, then everything might fall apart. And decentralized systems don't have quite such a problem with that because the cost of setting them up, in theory, is less expensive, less challenging. And if one party leaves, then it doesn't really matter. It can still function. Now, these benefits mean that you're favoring decentralization, which means there's no single owner. And it's important when you want data integrity, so you can be really sure that this data is true and I can check it. And when you want to have clear evidence if anything has been tampered with, because it's very difficult to, it's near on impossible to go back and change the past. So those are the values that decentralization brings, but it comes at the cost of centralization. And in so many cases right now, it's just not worth it, because when things are centralized, everything works faster. You can have faster throughput. You have stable governance. So if there's no single owner, then it's very difficult to make a decision. And governance is a huge problem in blockchains because you're not sure. You have to get everyone to agree on any decision, or a majority to agree on any decision. Whereas when a system is centralized, you can make decisions much more quickly. So that's a real problem in terms of speed and operations of a decentralized system. And the final is data privacy, because you can have different settings in terms of, or permissions in terms of what people can see on the public ledger. You can choose not to put certain things on the public ledger, but the reality is that in exchange for the tamper evidence and the transparency, you do give away some data privacy. So you can't stress enough that blockchains are worthwhile when decentralization is crucial to making something work. So that's why we say do something new. It's something that has been difficult to do so far because there is no decentralization. And that's part of the reason why we focused on digital identity and IoT, because those are two areas where we think decentralization can really help. So quickly, the value for telcos here might be in easing collaboration in multi-telco alliances, so where they're trying to work together, but it's been difficult to set up alliances so far, and potentially reducing costs and managing relationships across opcos for multinational telcos. And many people would want to debate the finer points of whether this is actually a blockchain or just a distributed ledger, and I think that's totally fair, but it's a spectrum, and everyone draws a line at a slightly different place. And if the best thing that blockchain does, the hype of blockchain does, is popularize decentralized ledgers, then lots of businesses will have won from that, I think. So moving on to our case studies. Let's look first at digital identity. So where's the problem with digital identity, or the problem/opportunity? Just to start off, I want to clarify that I don't mean authentication or single sign-on. And that's because this problem has already been solved by sign in with Facebook, sign in with Google, or most recently, sign in with Snapchat. There are lots of different ways that people can sign in that are already pretty frictionless. And actually, if telcos tried to solve this problem, then they lose a lot of the A2P messaging revenue that they're getting for verification codes. So there's actually a disincentive for telecoms operators to solve this problem right now. And I think that's part of the reason why something like Mobile Connect hasn't really taken off among telcos. So what we do mean is ID attributes. So more sensitive information, but also highly personal things that you need to share in order to get things done in your life, like open a bank account, apply for a mortgage, get car insurance, rent a car, prove your employment history, prove where you live. So all of those things are right now very non-digital. And so that makes it a time-consuming problem. I don't know, I'm sure people in the audience have all of their own experiences of having to prove their identity and, going to the bank and getting a piece of paper printed out and stamped and, sending IDs in and being without them for days. So this is a real problem that takes time out of people's lives. But it's a fragmented market. There are some solutions, but it's quite a fragmented market. And there's no clear mechanism for tracking consent at the moment in a digital world, which is part of the reason why it doesn't work. So we're already partway to solving this problem. And the World Wide Web Consortium has agreed on something called a decentralized identifier. And that's basically a pair of public-private keys that says, I am who I am on the internet. So it's a digital signature. And this, because it was agreed by the World Wide Web Consortium, it's already got buy-in from a large number of people. So how does blockchain help? Step one is it can work as a public register for decentralized identifiers for individuals. And these can be sort of improved by the fact that you can have another decentralized identifier that represents just my relationship with another company. So you could have a digital key where the public version is non-sensitive. It's just a string of numbers and letters that's digitized and represents my relationship with my bank. And another one that represents my relationship with my telecoms company, and another one that represents my relationship with the government or with the NHS in the UK, for instance. And if I need to prove something to somebody, then that's the public key that I share with them. So you could have a public register based on a blockchain where you share or where you store these public keys. The second point is you could have a time-stamped proof of consent. So you could log on a blockchain that at this time, this day, I consent for my bank to share that I have X amount, or that I meet X threshold of money in my bank account so I can apply for this mortgage. Or you can have a time-stamped proof of consent that says, at this time, Amy agreed that her mobile provider could share that she was in X location, which might be valid for a whole number of reasons, which we'll go through in a minute. So a company that's working on this is called Sovrin, and I thought best to ground it in a real world example. So here's a view of how Sovrin works. And you can see that there are 3 different layers. So in the middle, you have Sovrin validator nodes. And these are the companies that are providing the compute power to manage the blockchain. And these are usually companies that are the ones that have participated so far in here. It could be a telecoms operator might want to play here. The companies that are involved so far in Sovrin are Evrynim, and that's a company that wrote the blockchain protocol that underpins this system. You have IBM, obviously very heavily involved in blockchain solutions. KYC chain, which is a big provider of know your customer solutions based on blockchain for the financial services market. And there are loads of other security-based companies, digital identity companies, and including telecom innovation labs. So they're obviously linked with a telecoms operator that's exploring this opportunity. And we'll talk a little bit more about why a company might want to be a node. I'll just clarify that the next level is the observer nodes. So the validator nodes is sort of what goes on the blockchain. And the observer nodes are those that don't get to approve transactions. They don't provide the compute power, but they would have the ability to view what transactions are going on. So examples of who might want to view the transactions are companies that are relying on the Sovrin blockchain to prove that they are allowed to have this information about this customer, or somebody who might want to be able to prove the relationship that they have with a customer. So it's basically people who need to see the proof of consent and need to have access to the public identifiers. So if they wanted to find information about my relationship or find out something about my location, then they would be able to look at the blockchain that is storing my decentralized identifier link for me and Vodafone. So it's companies that are trying to engage with the blockchain for information, but are not actually processing and approving any of the transactions on it. The third level is a secure exchange of verifiable claims between any two agents. So everything in the gray and the yellow is on the blockchain. Everything in the blue is off the blockchain. And so on the blockchain, there might be a proof of consent that, you know, I allowed X company to look at my data, and that would be in a hash code. So you could only, you know, decrypt that receipt if you had the hash code. On the blue stuff is actually sharing sensitive information. So if I'm actually sharing my address with somebody, I don't want to publish that on the blockchain. Or if I'm actually sharing my date of birth with somebody, or any details about my bank account or any personal information, you don't want that traveling on the blockchain. One, because that's a security risk, and two, because that would add extra weight to the blockchain in terms of content, so it would make it work more slowly. So those are the three layers of the Sovrin blockchain. And part of the reason why we use this as an example is that this may not be the one that everyone rallies behind. There are lots of different companies that are working on digital identity related to blockchain, but we would say that telecoms operators are not experienced in developing blockchain protocols, and they're better off engaging with something that is already set up by experienced cryptographers and those who are software developers in this range. And also, you need several different organizations to be rallying behind one system if it's going to work, because if it's fragmented and everybody is working on a different system, then it's not going to be valuable to consumers. So the second part of how it works, we can see these are the players. So I'm the owner, and I have issuers, and they're the ones who issue claims about me, who will say who I am and you know, my personal attributes. So you might have a telecoms operator issuing claims about my location. You might have a bank that can issue claims about how much money I have or my address, or a telecoms operator could also verify my address. You might have the government who would verify things like, do I have a driver's license? Am I eligible for this or that public service? A telecoms operator could equally work as a verifier. So they go through know your customer processes and takes time to onboard customers. So that might be one area where a telecoms operator would play. In terms of the business model, you could have different payment plans, right? So for example, I might pay my issuer to prove my location or my address at a certain point. So if I'm applying for a mortgage or I'm applying for a service, I need to prove my address. And this usually right now costs me an hour of time and potentially a couple of pounds. You wouldn't necessarily want to take that business model because consumers might expect to have a digital solution for free. So for example, if I needed to prove that I was in X location in order to make a claim on my car insurance provider, my car insurance provider might actually, as the verifier, pay the issuer of that claim. So my car insurance provider wants to know that I was on the M4 at 10 o'clock this morning. They could directly pay my telecoms operator for that information because it's valuable for them to make sure that this isn't a fraudulent claim. Likewise, a verifier might directly pay an individual to gather information for their advertising campaign. So how valuable is it for a shop that I like or a ride sharing company that I subscribe to know where I am at certain times of the day? And they can get that information now through third parties, but it might be even more valuable for them to get that directly from me if they could. So now the big question is, where's the money for telcos in this Sovrin ecosystem? So in terms of using blockchain to save money, we would say one thing is to manage consent for GDPR. So all businesses operating in the European Union, and some have adopted this outside of the European Union as well, will need to be able to prove that they have consent to share the data of their customers. And lots of companies will have mechanisms to do this already, but we won't really know what is acceptable until the law has been tested. But generally, it would be valuable for companies to rally around a sort of universal solution, because that will make it cheaper and it'll make it more scalable. So this is one potential option. Another option, as I noted before, is more efficient know your customer processes. So if you're onboarding a customer and they're already verified on the Sovrin blockchain by a bank, then you don't have to go through and do the whole know your customer, because you can trust that the bank has already verified them. And that speeds up the process for onboarding a new customer. It's cheaper and everybody wins in that situation. And this is perhaps less important for telecoms operators, but for a lot of smaller companies, once you have sensitive data about an individual, then you have to store it carefully, and you have to protect it, make sure it's not stolen. So you can use things called a zero knowledge proof, where you don't actually share the sensitive information, you just say that they meet your criteria. So for instance, if I'm buying alcohol online and want to prove that I'm over 18, I can just have the government verify that I am over 18. They don't need to actually share my date of birth, which the retail company would then have to store and would be problematic for them or costly. So that's using blockchain to lower costs. The other side is to use blockchain-related services for new revenues. And here is where we think about, okay, why would somebody want to be a Sovrin node? So one might be if a telco is making a big play into digital identity or somewhere in that field, then by joining something like Sovrin or Sovrin itself or something else, then they would build credibility in that area. They would be able to prove that they're abreast with what's going on. They would be able to offer some of the additional services around secure data sharing, so everything that happens off-chain, of sharing the actual personal information. And if you were a node, those are the ones that control what transactions get approved and what don't, and you have control to a certain extent over the governance of the ecosystem. And if you are making a play in this area, then that might be important. Finally, I think that the goal of this eventually is to create a data marketplace. So right now, as a consumer, there's really no value, no opportunity to charge for my personal data. I have not really any choice but to give it away for free in exchange, yes, in exchange for services. But if I don't want to give my data to Google, then I really lose out on a lot of services, and there aren't really that many good alternatives. So a system like this could sort of reverse that and create a marketplace where there is actual value for consumers directly in sharing their personal data. So moving on to the next use case, IoT. So where is the problem / opportunity? And obviously, I think that this is going to be no surprise to anybody. Lots of people see this, that right now the IoT landscape is highly fragmented, and most people are focused on connecting devices for very specific applications. And what that means is that all the data is really siloed. Whereas, one company gets a load of sensors together and has all its data and can communicate within itself, especially if it's in a single location. But between companies that have different data, it's very difficult to get the data out of the silos in order to really, make everything talk together directly and, deliver on the promises of something like a smart city where everything interacts together seamlessly, because all of the data is still in these silos. So we think that we're really still at the very beginning, and the full potential of the IoT is not being realized. And this is problematic because it means that there's only still a limited value in companies paying to connect all of these sensors, because it's only as valuable as it is internally, and they're not getting any of the external benefit of engaging across an ecosystem. But you can't have a central authority for this. You can't have a honeypot. That's a repository of all of this stuff in one place. But also because companies have different priorities and they need different types of systems, and you're never going to get everyone, obviously, to agree on a single system. So there needs to be another way to ensure trust between the participants in the IoT so that they can share data, and also permissions about who is allowed to see what data when and at what cost. And so this has blockchain all over it in my perspective. So going through a little bit what the IoT needs to fulfill its potential, and we sort of see this as a step diagram. So step one is we need some kind of DNS layer to make things discoverable. So if I want to find out what the water pressure is at a certain location at a certain time at an interval of 5 minutes, and I want to be sure that that data is accurate, how do I find that? Where do I search for that? So that's step one. Step two is, once I know that there's a sensor that is going to give this data to me, how do I shake hands with it? How do I establish a relationship? And I have this one in light blue because I think that there's a strong potential for a blockchain here, because you could use a provenance blockchain by saying where the sensor is from, who manages it, what it's, that it's securely configured, so we can look at its history in order to trust who it is and know that, okay, I can safely interact with this device. The next step is, does this sensor want to share the data with me? Are they sure that I'm not a competitor that's going to use this data for a reason that's going to harm my business interests, or for whatever reason, are they willing to share this with me? And this is sort of a smaller opportunity in IoT to track permissions of who can access and who can't access the data that I have available. Step 3 is the actual peer-to-peer transaction. And if, or rather when, the promise of IoT comes true and you have billions of devices that want to interact with each other, it's almost unthinkable to have all of these transactions go back to a centralized database, which then manages their transaction and does a settlement and then goes back out to the device. You can see this creating a big bottleneck, and the devices want to be able to connect peer-to-peer without going through a centralized system. So there's another opportunity here for smart contracts and potentially an embedded token where devices can interact directly based on conditions X, Y, Z. You can sell this data to anybody with these conditions in exchange for this token, and for all of that to be managed on a blockchain in a decentralized fashion. The final step is to share that data securely. And for the same reasons that we talked about in digital identity, this should not happen on the blockchain because it makes it too sensitive to decryption and theft. The final stage is that the IoT is messy and it's not as linear as this graph suggests, and you need to be able to send and receive data. So this all needs to be able to go in all kinds of directions. So it can't just be linear in this way that we're talking about. And a decentralized system where you can create peer-to-peer connections might be able to enable that. Now, the key problem here is that these, to me, look like two different blockchains, where on the one hand, a provenance blockchain requires some pretty heavy cryptography, where you need to store more data about who somebody is, and you need to have this really long traditional blockchain where you can track where a device has moved through time and who has owned it through time in order to prove where it comes from. So that means that it's comparatively slow and pricey. But on the other side, peer-to-peer transactions, they have to be light in all senses. They have to be light on compute power, and that's because a lot of IoT devices just won't have the ability to engage with a heavyweight blockchain. It has to be cheap, because if all this data is expensive to buy, or the transactions are expensive to process, then it just won't make it worthwhile. All of this is really a volume game. So the technology enabling it, as well as the cost of buying the data, has to be low. And it has to be fast. It has to happen as quickly as possible. And I'm sure we've all heard about how long it takes to process a Bitcoin transaction, an Ethereum transaction right now, which would be untenable if you were trying to manage billions of transactions between separate IoT devices. And I think that a good example of why the peer-to-peer transaction wouldn't work is looking at a protocol called Tangle, which is not quite a blockchain, but borrows some of the technology, but is one of the leading technologies in the IoT space. It's created by a company called IOTA. But Tangle doesn't have any memory. It doesn't keep a memory of what happened in the past. It's not a traditional blockchain where every block contains all the history of the previous one. So it wouldn't be able to track provenance, even if it could manage peer-to-peer transactions. So I'm conscious that we've overrun, but we're nearly done. Just thinking about now where could telcos play in this? And I think there's sort of two levels. The first level is participate in ecosystems that are making this type of stuff happen. And you may not engage directly or build any services on top of it, but if you don't get engaged in the ecosystems that are making this happen, then it could stifle the growth of IoT. So there's a strong case for participating in this type of ecosystem just to boost the connectivity revenues that telcos could get from the Internet of Things. The second aspect is thinking about developing blockchain-enabled services for something new. And I think what lots of people might be thinking here is that there are a lot of steps here, and this is complicated to do, and how can we make this easier for the devices, easier for people to use, to enable? And we think that there is real potential to try and combine some of the steps. So if you take the DNS layer to make things discoverable and pair that with how to establish a relationship, you could, as a telco, for example, have a list of highly discoverable items that you have, all the devices that you connect that are willing to sell their data to somebody externally and pre-validate their identities on blockchain. And so when somebody wants to buy that data, they can just go and say, oh, look, this sensor is selling that water pressure data at 5-minute intervals, and it's already been verified by this highly trusted telecoms operator, and they verify it on this regular basis. Okay, great. I just buy that immediately. So you don't have to go through all of the checking the provenance by itself, and this could include the consent level as well. So we think that there's a potential opportunity for telecoms operators to engage in reducing the number of steps for end users and then connecting this to peer-to-peer transactions. And might see this as attempting to move up the IoT value chain into the services layer, into making it easier for bringing to life the true potential of the Internet of Things. So we'll end there and just leave you with our key takeaways based on these examples. So I think the first one is that whether you're looking at digital identity or IoT, a lot of these systems are trying to do the same thing. They're trying to prove that data is authentic. They're trying to manage consent. They're trying to prove consent in an auditable way, which is increasingly important from a regulatory perspective. But they're trying to create a data marketplace in both instances, whether it's digital identity or in the IoT. It's been very, these markets are really fragmented, and there's no really good digital solution for how can we share this data or sell this data securely and track consent and make sure the data is what it says it is in order to generate value for all players. And so that's what a lot of these solutions are trying to achieve. And we think that IoT is a much better immediate bet than digital identity. And that's because enterprises have a headache now where they can get the IoT data into their silos, but they can't get it out again. And consumers sort of have this problem, but it's not necessarily something that they're going to pay to resolve right now. And there are also fewer regulatory barriers around enterprise data. So it's not the same as not as sensitive as individuals' personal data. But at the same time, enterprises are willing to pay for the security as well as the value that blockchain can potentially provide in the IoT, whereas consumers might not, a very small percentage of consumers might be willing to pay for security, but most of them won't yet. The next is that most telcos don't specialize in software development and cryptography, so don't try and build your own blockchain protocol. I think that there are loads of companies that specialize in this, and many people who do specialize in cryptography or have been working in blockchain for a long time are still having a lot of trouble figuring this out. I mean, if you just look up the Google Ethereum and the problems that it's been through, this is a group of highly experienced people looking in this area, and they still are struggling with governance issues and all kinds of issues around managing blockchain. So this is not telco's area of specialty. We really think that telcos should think about how they can engage in existing blockchain ecosystems in order to add value for their customers. And finally, the most distinguishing feature of blockchain is that it's got distributed ownership and control. There's no centralized owner, and therefore it makes it easier to trust the other players that you're working together with, because you all have a sort of even level of control. So when you're getting engaged in a blockchain ecosystem, don't try to own it, but figure out how you can partner together. And this is a little bit of a departure from how telcos have sometimes operated. But for those that do want to get involved in blockchain, I think that it's key to remember that this is the greatest value of the technology, and that's where it's going to come into its own. So we'll end there. If you have any questions, please type them in. I'm sorry I didn't remind you throughout the webinar, but I don't know, Darius, have you seen any questions in the box?
So we do have one, and it's about the limitations of blockchain platforms. And it's really, there's certain protocols that have a maximum number of transactions that they could actually handle. And if there are certain protocols that can handle more transactions, why is that? Like, what are they actually doing differently? And how would that apply into this kind of ecosystem of how useful they are in these use cases?
Well, I think that basically the blockchains that have a limited number of transactions that they can process in a certain number of time often comes down to the consensus mechanism that they're using. So Bitcoin is notoriously slow and consumes a huge amount of power because the consent mechanism is really complicated. And they've done that so that it can be completely decentralized and anyone can participate anonymously. Or well, there are ways to track people on the Bitcoin blockchain now, so it's pseudonymously, and that's hugely expensive. So a lot of the blockchains that I've been talking about now, and you're right, I should have clarified this at the beginning, would be either public permissioned blockchains, which means that they are open to the public, but you must have your identity validated. You must be participating as yourself or as a confirmed identity on the blockchain. So that reduces the amount of compute power you need in the consensus mechanism, because we've already proven your identity. Every time you're processing a transaction, you don't need to reprove this person's identity by checking everything that they've done on the blockchain historically. Or it might be a permissioned blockchain where only a certain number or a certain list of actors are allowed to participate in that blockchain. And that might be where you have telcos collaborating between each other for any type of potentially settlements, roaming settlements between telcos, and it's just permissioned between the telcos that are working together on this, and so it's not open to the public. It's only open to the participants, and the consensus mechanism there can be again lighter because you already know who everybody is, and you don't need to revalidate their identity, or that they have the assets that they say they have every time you process a transaction for them. So it's about, finding the layer that works. And, you know, within the public blockchains, a lot of the development work that's going on now is in terms of how can we maintain the security, but make this a bit quicker. And you have lots of offshoots, like the Lightning Network, which creates channels that are little operate on the side of the Bitcoin blockchain, where people can you open a channel and you share, you can make transactions directly with somebody who's already been validated on the blockchain, and then eventually, whenever you want, you can settle. And so you only publish a transaction on the blockchain when you want to settle and close your accounts with whichever party you're interacting with. And so that allows you to do a large number of transactions with somebody else without directly tracking them on the blockchain every time, and thus making it quicker.
So we've actually had a couple of questions that are about if any telcos have made any progress in this, whether there's any that are doing well, any that have even at proof of concept, just kind of a tracker on any telcos that are actually playing in this space.
Yeah, I would say that actually there are a lot of telcos that are playing in this space. There's an organization that I think is called TBCA Soft, and I might get back to you by email, where several telcos are working together, and they've done a proof of concept about roaming settlement. I'm really sorry, the name of the telcos escaped me right now, so I'll have to get back to you. But definitely there are a lot of telcos are sort of at the proof of concept stage, and they're trying out different things. And I think digital identity and IoT are areas that they're interested in, which is sort of why we chose them for our topic of discussion today. But I would say, despite having proof of concept, it's probably still quite far away from any kind of commercial rollout. And if there is a commercial role, I don't think that it's going to be a game changer tomorrow. For instance, it's still a really young technology, and so everyone is still getting to grips with it. But definitely, there are telcos that are testing it out in various different ways. And I've actually just remembered, Verizon is a customer of guard time, which I mentioned at the beginning of the webinar, and they're using it to track security in their network. So that's actually a live example, but working with a company, guard time, which is really mature in this space and has years of experience working with the Estonian government, for example. Any others, Darius?
This is kind of more from a regulatory standpoint. If you're relying on the blockchain for things like age and to know your customer information, if there is an error, who is liable? Is it going to be the issuer or is it the validator?
Yeah, I'm not sure. I don't have an answer for that yet. And I think that's part of the reason why digital identity is difficult, because in order to have an answer for these solutions or for these questions, you need the regulators to be involved, and you need a lot of different players to get involved for this to be valid. So I think that's, one of the main reasons when you come down to there are fewer regulatory barriers in the IoT, because enterprises can choose to do what they want with the data that they own. Whereas when you put your personal data into the public space, that's not just necessarily how I think you should be allowed to use my data. It's how the government thinks you should be able to use my data. And I think that we're still a little while away from having clarity on that. So it's more of a test case for now that may have um, some earlier opportunities. For instance, one example that I heard uh, from that I heard on a call with a colleague, or not a colleague, a customer, was about telecoms operators using the Sovrin blockchain for know your customer for cryptocurrencies. So there are lots of people that want to use cryptocurrencies, but they don't have anywhere to go through the know your customer um, problems. It's a really time consuming and challenging thing. And, could telcos just use a Sovrin blockchain to run that? They already have places where customers can get known. So we might see some early use cases come out that way that are less in less regulated areas.
Perfect. And I think the last one that we've got is just about the first use case that we went through in the case study about Sovrin. And are they seen as quite unique and well established? Are they quite a lot further ahead than other kind of digital identity providers and protocols, or are they the only one that's doing it?
They're not the only one that's doing it. So there, for example, one of the companies that is operating as a node, KYC chain, they do digital identity, particularly for financial services. And if you go on Sovrin and look at some of the other companies that are supporting them, they are also involved in digital identity solutions. There is likewise a Spanish company that I believe is on one of my earlier slides that is working towards a similar digital identity solution, particularly in Spain. So a little bit, they might end up moving a little bit more quickly, even if they're not global. They're working within a particular country. So some of these regulatory issues are some that they might be able to tackle more quickly. I apologize, I don't remember the name, but I do believe that it's on one of the slides at the beginning of the presentation. And if not, I can email you. All right. Well, I think that we are at the end of our webinar. Thank you very much, everyone, for attending. And if there are any further questions, please don't hesitate to get in touch. And you should all be able to access this recording through the same registration link shortly after we finish. Thank you very much.